Greetings, everyone. We have a few folks filtering in. This is our third and final winter workshop of the season. The Underwood Conservation District is sponsored, so thank you for being here. This is great. I have to give credit where credit's due. Corey Podolak here with UCD has organized this series this year. And if you work at Underwood CD, raise your hand. We've got Mia and Dan here in the room as well. If you're a board member of UCD, raise your hand. Nice. We have Joe and Barbara. Thank you. Yeah, we are recording this presentation so that we hopefully have it in the future on our web page for future reference. So that's why we've been messing around with the screen. But just to get us started here, my name is Toby Stillinghass. I'm the director at Underwood Conservation District. Again, this is the third and final workshop of the season. We're honored to have Lindsay Cornelius join us from Columbia Land Trust to talk about prescribed fire and its role in the environment here. You've probably all been here before, but the restrooms are behind us. Help yourself to snacks and tea and drinks over there if you want. In the back, we have information about Underwood Conservation District, and I'm going to just run through a few of our slides just to tell you more about Underwood Conservation District. And if you want to stay in touch, if you're not already, you can always subscribe to our newsletter. So that's a great way. We don't spam you, we don't send out unnecessary things, except we do send every other month newsletter. So you can stay in touch with what we're up to that way. Let's see if this works. All right. Underwood Conservation District, we have a long-range plan and an annual plan, and these are the main topics of work that we cover: forest lands, agriculture, working lands, urban environments, habitat, native plants. That includes a lot there because we work in stream and we work on riparian areas and upland as well. Plus, we have a community engagement aspect of our work, which includes events like this and a sustainable operations side of things. This is our updated mission statement that Underwood Conservation District empowers voluntary, locally led natural resource stewardship, helping ensure thriving communities, land, and water for future generations in Skamania and Klickitat counties. We have existed for past 85 years. We just celebrated our 85th anniversary in 2025, and we've been growing. Our staff is 11 strong these days. So you can see we've got a slew of wonderful talent on board right now. And I just want to highlight a few things that we're up to. We're developing a nursery, a native plant nursery out of the Wind River, the historic Wind River. And if you have heard the history there of a large nursery, we're not there yet at that scale, but we are growing potted plants out there. And we started a fall plant sale. Just this last fall was our second plant sale out there. And so we've joined up with Logtoberfest. So next year we'll probably be doing the same with Logtoberfest up there outside of Stabler. And one of the reasons we are doing this is for the potted stock. You might be familiar with our bare root seedlings sale in the spring. And this one is designed to be more around potted material and fall planting. Crop Talks are another event. Corey here organizes those. In 2025, we had 108 people attending these with 7 different farmers in Oregon and Washington. So we alternate partnering with Forage Grown. So stay tuned. It's kind of our counterpart to the winter workshops. We get out and tour farms and talk about all things agriculture. You might be familiar with our food and farm tool library. I know we have some active customers in the room here. This is just a smattering of some of the tools that we have in that tool library. And the reason it's food and farm tool library is because we do have food preservation materials as well. We're growing, and the number of patrons there is growing, so it's very exciting. I wanted to include this slide because we've partnered with different vineyards and orchards, Core Cellars being one of them, using some of our tools. So the no-till seed drill is one of them. They sow cover crops between their vineyard rows. They also use the manure and compost spreader between their vineyard or between their rows. And then that vineyard, and we were featured in a Washington Grown episode that just aired a week or so ago. You can find it on YouTube if you're interested, called River and Vine. But we're also doing other sampling and providing soil samples to folks annually. So get a hold of us if that interests you. We're doing a lot of planting projects. These are some pictures of different riparian areas on the White Salmon River and Trout Lake Creek where we're doing riparian plantings. And we're doing stream habitat projects. So you're getting a sense of the variety of work here. This type of work can take different forms as well, where we place large wood in different streams, and we also do an occasional fish passage project where here you can see the original culvert and now the newly built bridge to provide passage for migrating fish to access habitat. So those can take different forms, and it's exciting work, that's for sure. And I feel like I skipped a slide, but we did have one about our native plant sale that is happening this now online, and then this spring we have Tree Fest, which is scheduled on March 21st. So if you haven't put that on your calendar yet, remember that Tree Fest does happen in White Salmon every spring, and that's our spring native plant sale where we sell the bare root seedlings. I'm gonna let Dan go ahead and talk next about the Forest Health and Wildfire Program and introduce Lindsay.
Thank you, Tilda. So we do a fair amount of work with wildfire mitigation. You maybe know it's we're going fire go through, and so we have recently started doing post-fire, but for years we have tried to get the word out about how folks can reduce wildfire hazard on their property. And I'm happy to chat with people. We do free home defensible space assessments, local shipping, and a variety of other services in that realm. Following Bordeaux fire, turns out our state and local agencies don't have a really tried and true approach to post-wildfire services. So we need more of that as conditions have changed to become, well, a longer, hotter, drier, more destructive wildfire season, unfortunately. So I think this is something that we will increasingly try to grow and be able to leap into action when necessary. But enough about us. Let me tell you about Lindsay. Lindsay Cornelius grew up with her family in Clark County, Washington, often outdoors, and then went to school and earned a degree in environmental science at Western Washington University. She went from there to accepting an AmeriCorps position with Columbia Land Trust. Didn't know that. I was also once upon a time an AmeriCorps volunteer, or intern, I should say, with Underwood Conservation District. Lindsay parlayed her AmeriCorps time to a career at the Land Trust, starting more than 20 years ago, and discovered that caring for land trust lands is a really wonderful kind of applied science. She now supervises a team of people helping to care for land trust lands, and also manages the East Cascades Oak Partnership, or ECOP as we call it. ECOP's a large regional collaborative of public and private partners that work together to leverage resources and knowledge and try to begin implementing more adaptive and informed management of oaks and oak pine forests of the East Cascades. Lindsay's still excited to be learning more than ever about climate impacts on our local forests and our relationship with fire. She's going to share some thoughts tonight. Please welcome Lindsay Cornelius.
Okay. Yep. You do. I like to walk and talk, but I think I need to stand in front of this because they're recording. So now you're gonna see me all. Maybe I'll leave and come back again. Yeah. Right. Cursors. Funny. Oh, there we go. There it is. And I'll see. But there we are. I think you're good, hopefully. This is a drone image of a prescribed burn that I got to attend this last year. You can see the people. Yeah. This is me over here. Kind of fun. All right, well, I am with Columbia Land Trust, and Columbia Land Trust is a nonprofit that's based in Vancouver, Washington, and we have regional offices in Hood River and for White Salmon and Astoria. And we conserve and care for the vital lands, waters, and wildlife of the Columbia River region through sound science and strong relationships. And to date, we've conserved about 60,000 acres. That extends from the coast in both states, Oregon and Washington, along the Columbia River to about the John Day River on the east side of Cascades. And so we work across many counties and across many what we call ecoregions to do conservation. And our conservation work takes a lot of different forms depending on the community that we're working in and the conservation values that we're working to protect and the community needs that exist in parallel with those goals. We do conservation easements, we buy and manage land, we have a carbon mitigation program, we have a backyard habitat certification program in the Portland and Vancouver areas. So we have a wide variety of program work that helps advance our goals. But I'm going to talk with you tonight about just a narrow aspect of that work, and that is managing fire adapted forests. I'd like to start by just thinking a little bit about how each of our relationships with fire. How many of you have been evacuated during a wildfire? Has anyone had their property burn in a wildfire? But we've all been close enough to feel the sweat. Fire can be a very traumatic event for people. You can lose homes, you can be injured, you can lose your life or someone you love. So really important that we honor that trauma and acknowledge that that exists and that that's a really meaningful experience with fire. And also explore the other aspects of fire that we routinely experience. In my life, I use fire in kind of a loosely ceremonial way, birthday candles and such. We cook on fires when we go camping. We organize around fires to share stories and music together. So my family uses fire in a pretty recreational way. And it wasn't until with Columbia Land Trust several years ago that we started using it in a different way, in a kind of restorative way. And so that has really been reshaping my relationship with fire. And a lot of the news that I swallowed and still swallow from the mainstream media are the big sensational fire events. You know, you hear about the really rare occurrences when a prescribed fire gets out of control and damages property. You don't hear about the literally thousands of other prescribed burns that are successful throughout every year. So I'm going to share a little bit about my journey and about what I've been learning about prescribed fire, and you guys can ask questions along the way if you'd like. Fire often looks like disaster, right? We see the burned materials and we see the black char and the white ash, and we think, oh, destruction. I look at this and I actually see renewal and I see hope. And so I'm going to share with you why I'm seeing that throughout this presentation. But before we get there, I'm going to set the stage a little bit about why this region is just so remarkable. You all know we live in the Columbia River Gorge. You feel its winds on a regular basis. This is the only place on the planet where a continental scale river the size of the Columbia River bisects an active volcanic mountain range at the leading edge of a tectonic plate. This is the only place in the entire planet where that exists. Congratulations, you live here. You get to experience all the things that come with this remarkable gorge. One of the things that this gorge does is it allows all the kind of more temperate air from the Pacific Ocean and the west side of the Cascades to flow through the gorge and moderate the more extreme continental climate on the east side of the Cascades. And so we live in this really interesting kind of mixing zone where we have plants like Oregon white oak, which is a Mediterranean plant. It enjoys the climate on the west side of the Cascades, but it can establish here because of the Columbia River Gorge. So the gorge creates really unique conditions, and that drives really fascinating plant communities and animal use of those plant communities. So a lot of really interesting diversity happening in the gorge. On top of that, this is a really amazing place in that you transition from, more than 160 inches of precipitation at the crest of the Cascades to less than 10 or 12 inches on the Columbia Plateau. And you go from over 11,000 feet at the crest of the Cascades to 140 feet or so on the Columbia River. And you're making those transitions in elevation and temperature over the distance of only about 40 miles. It's extremely steep gradients. You look at the maps of the world, and there are very few places where that transition happens so abruptly in combination with temperature and elevation. That drives a lot of interesting biodiversity, and you feel it in your body when you drive through the Columbia River Gorge. When you're on the west side of the gorge, it feels wetter, right? There's conifer trees everywhere. You transition to the white salmon the river area, and you start to see more oak, a little bit more open conditions, more ponderosa pine. And then you get out toward the Dalles and Goldendale, and you're in kind of grasslands and shrub steppe. So you're feeling those transitions in your body. These transitions give rise to this kind of broader area to high levels of biodiversity and climate resilience. And even our dry forests, which, we kind of think about, we have a bias when we think about life. We think about it being supported by these lush green verdant forests. Our fire adapted forests are incredibly rich places. They might turn brown in the summer, but they host an amazing diversity of life. And so we're going to celebrate those with this slide. These are some of my favorites. And we're going to start talking about how fire affects some of those organisms and how the fire cycle is so important to forest health. While I'm talking about fire, I'm going to use some terminology. So I just want to go over what those things mean before we start in. You'll hear the terms fire intensity and fire severity. And fire intensity is basically a measure of how hot and intense the fire gets while it's burning. It can be measured in things like rate of spread and flame lengths or flame heights. Fire severity is the impact that the fire had after it burned through. So you can measure that by how much tree mortality there is, or how hot the soil got, how much ash there is, how much the char heights on the trees. Those are indicators of fire severity. This is an example of a low severity fire. You can see that for the most part, all the trees are still intact. Some of the coarse wood that was on the ground during burn day have been consumed. This is an example of a high severity fire. This picture on the left is of a gentleman who's part of the East Cascade Oak Partnership up in Goldendale, and he had a summer fire on his property, and it got into the riparian area around these big old oaks, and it just cooked them. So you can have high severity fire on small scales, and you can have it on really large scales. And we'll talk about the largest scale fire that this country has seen in a few minutes. Other terminology you'll hear me use is surface fuels. Fuels are just things that will burn in a fire. When we're talking about surface fuels, we're talking about things that are on the ground. So that can include leaf litter, pine cones, grasses, shrubs, and big pieces of down wood. When a tree dies and falls over, that's considered a surface fuel. Ladder fuels are the fuels that ladder up into the crowns of the trees, and fire can advance up that and into the crowns of the trees. Those are typically things like young trees, the heavy branches growing low on more mature trees can be considered ladder fuels. This is just the state of Oregon, but across the entire globe, you can characterize what's called the fire regime of any place that you live. And the fire regime is basically just, it describes how frequently and how severely fire is expected to occur based on how receptive the fuels are growing in any location. And that's a function of what type of plants are growing there, the structure, like how they're growing in relation to each other, and then weather, how dry, hot, and windy it gets. It's a little bit complicated graphic on the right, but you can see in the left column of that graphic, this climate ignition driven system. That's basically describing like the lush verdant forests on the west side of the Cascades. So, on the Oregon coast and on the west side of the Cascade Range, you have forests that only experience fire after several hundred years. And the conditions that have to come together to make those forests burn are primarily driven by the climate. And then whether someone is there to light a fire or not. In the forests where we live, they're fuel driven systems. So that means that the weather conditions frequently will support fire. And whether something burns or not is a function of whether the fuel is present. So in a forest that recently burned, fires are less likely to start. But as fuels grow and develop in those places again, they'll burn again. So you have a more frequent return of fires because the weather conditions support it and the fuel is developing. Does that make sense? So how are forest fire adapted? They're adapted to fire because they regularly experience it. It's not different than, the animals in a tidal pool being adapted to the ebb and flow of the tide, right? These are organisms that evolved with frequent fire. And so a lot of the plants that we have in our landscape have developed features that allow them to cope with fire. Some plants have actually developed a dependency on fire. Their seeds won't germinate unless they experience fire. It's like lodgepole pine. Other species adapt resistance strategies. So ponderosa pine, for example, they have really thick bark. And following a fire, they actually increase their production of resin ducts. Those are little structures inside the stem of the plant that produce sap and pitch. And when a wood-boring insect tries to drill into the tree, if they hit one of those little pitch pockets, it explodes out of the tree and it expels the insect. So it's a really important kind of immune system thing that ponderosa pines have developed that is improved by fire. So we have this kind of thought in our head that fire must weaken plants. It doesn't always have that effect. Sometimes it actually strengthens them. Ponderosa pine also have what I call like high skirts. You can kind of drive around, you can see ponderosa pine boughs. First of all, the branches are pretty sparse, and that allows the heat from fires to move up through them. It doesn't trap the heat of fires down low. And so you get kind of different fire behavior because of that. They also, fires will kill the lower branches of ponderosa pine. And so it's almost like moving the bottom of the tree up. You can think of it as like lifting up your skirts to step over the fire, right? If your skirt's down low, the fire is going to climb up your body. If it's up here, it doesn't do that. So ponderosa pine have evolved this feature that allows them to have kind of like these high crown heights. They also have needle cast. They shed a third of their needles every year, and that builds this fine fuel bed that's receptive to fire at their feet. So they're almost like self-promoting low severity fire by creating a fuel bed at their feet. Oregon white oak is another plant that's developed a lot of resistance strategies to fire. They have really thick, waxy leaves that resist ignition. It's actually kind of stunning to watch Oregon white oak in a fire. Hot, dry, windy conditions, they're going to burn. Anything's going to burn in those conditions, even metal. But in Oregon white oak's case, they have really high resistance to flammability. They also have really thick bark, and the thick bark is important. That protects the buds that are dormant in the tree from the heat of a fire. So both ponderosa pine and Oregon white oak have really thick bark, and that prevents them from losing the ability to produce leaves the next year or new branches when they need branches. Douglas fir, conversely, has pretty thin bark until it gets really old. So historically, there were fewer Douglas firs in these fire-adapted forests than there are now. And they're here now because we've been suppressing fire on the regular. So you have a lot more Douglas fir in this landscape than historically.
So Lindsay, what was the picture in the upper right corner?
Oh, thank you. I didn't mention that. That's stump sprouting. So Oregon white oak also have this amazing feature that allows them to be resilient to extreme disturbances. The top of the tree can die from someone cutting it down, like is in this case in this picture, chainsaw, or a fire can burn it and fully consume the top of the tree. And then the buds that are dormant in the root crown of the tree will resprout, and your tree is growing again. It's going to have a different morphology. It's going to look different than it looked when it was a single stem, but it's still going to produce acorns and leaves it's still gonna make flowers, it's gonna grow. Eventually, sometimes those trees end up, the sprouts will thin out over time, and you'll end up having like 3 or 4 or 5 big dominant stems, and they'll grow together over time. It's kind of cool to see sometimes. Like I've seen trees in town cut down, and you can see that it's 5 stems that grew together. Looks like one tree. This is Dr. Andrew Merschel from Oregon State, and he did a fire history study on the Mount Hood National Forest. And so if we want to understand how regularly fires burned in the landscape, this is one tool for understanding that. You can also talk to your Indigenous elders who have oral histories about fire history in this region. In this case, he is looking at the fire scars on these trees. So every time, not every time, but when a fire burns hot enough to damage the cambium, the outside layer of the bark, but not kill the tree, it creates a scar on the outside wood, and then the tree grows over it. And so you get this kind of like undulating wave pattern of scars on the trees. And you can go out and sample these stumps and these old snags for fire scars. And then you can compare the growth rings that's in a database for the entire Pacific Northwest. You can look at weather trends, which dictate how big each growth ring gets each year based on how much moisture is available and the growing conditions for that year. And you can actually discern, like you can age, you can date the rings on a tree. So you can understand its context and history, and then you can reconstruct how frequently fires burn. You don't have to understand this except for that each horizontal line represents a tree that was sampled for its fire scars. Each of the dark colored triangles represent a fire scar. And you can see that, of course, we don't have a lot of records that are much older than the 1600s because a lot of those stumps are dead and gone. But in one case, we had this, what you'd call the super recorder tree that established in the late 1400s, lived until the late 1800s, and recorded more than 31 fires in its history. So that tree saw a lot of fire. You can see that, you know, when fires occur and shape these kind of older growth trees, that they're pretty widely spaced, they're pretty open grown. Stand replacing fires are really rare in these systems because fire just doesn't have enough fuel to build a lot of heat. It doesn't get up into the crowns of the trees and travel from tree to tree to tree. And so these forests are kind of open ground, they're clumpy and they're what we call clumpy gappy. And that's because fire, when it burns through a forest, doesn't burn everything the same, right? There might be a gust of wind and it skips a 2-acre patch. Or there might be there's this plant called Ceanothus prostratus in our woods that resists burning. And so if there's like a big patch of that, the fire moves around it and maybe it doesn't come back, you know? So there's a lot of ways that fire is highly variable at these fine spatial scales. And it creates this kind of patchiness in our woods that adds some richness and diversity. This is just another example of a fire adapted forest. It's one a little bit less mature. The trees are not as big, but it shows kind of that structure, that openness. So you can see on that fire history graph that something dramatic happened in the early 1900s. And in fact, there were several things that happened in the early 1900s that led to our current day policies around fire suppression. One was that Indigenous people were forcibly separated from the landscape that their lifeways helped shape. So they used a lot of fire, and if fires were naturally ignited, they weren't putting them out. They didn't have any reason to do that. So the removal of Indigenous lifeways from the woods has had a pretty big impact on the current state of forests, and not to mention the culture of these people. Another thing that happened was that we had one of the biggest fires on record on this continent. It's called the Big Burn in 1910. It was actually 3,000 different individual fires that merged into one huge fire. And this occurred in the northern Rockies across Montana, Idaho, and Washington. It burned many towns. It killed 78 firefighters and was hugely traumatic. It covered 3 million acres of forested lands. This was caused by, this is that kind of convergence of weather events. There were multiple long years of drought, followed by a horrific lightning storm in the middle of the summer. And those conditions all conspired to create this enormous burn. This inspired the US government to start thinking about fire suppression in a very different way. And so alongside the commodification of forest products, where we started to kind of think about our forests as a place we could generate income and that could produce commodities for our communities, right? It's a busy time in the early 1900s. A lot of building is happening. We need wood. So a lot of our forests started to be managed as plantations. And that also contributed to the need to suppress fire, because now you're looking at dollars standing out there in the woods and not just trees. And so you have a resource that warrants protection. All of those changes have contributed to a densification of our forests. There are just simply more trees out there than there used to be. This creates a lot of different stresses on the forest and the way that it will experience fire. For one, there's a lot more fuel out there. So fire is going to behave differently in a forest that looks like this than in a open, patchy, large tree, high canopy forest. It's just going to behave differently. This is what a fire suppressed forest looks like, where those big old trees still exist. Okay, now they're surrounded by a younger cohort of trees, often Douglas fir, which are less fire adapted, they're less fire resistant. And so when fire does start in systems, it's going to burn differently than if they were ponderosa pine. The other thing that proliferation of trees does and that forest densification does is it creates competition stress in individual trees. So when you're a tree and you don't have a lot of other trees around you, you have a lot of resources. You know, your roots are down and they're deep and they're wide, and you're accessing nutrients and soil or water from the soil beneath your feet. When you have 2,000 neighbors, your access to those resources changes considerably. And that puts a lot of stress on trees. When trees experience drought stress, they get into this battle between if they should open their stomata and respire, right, which is necessary for making food from sunlight. To photosynthesize, you have to be able to open your stomata. Those are the small pores in the surface of the leaf that allow the plant to take in the gases it needs to create sugars. And that is literally plant food from the sun. So you got to be able to open your stomata. When you open your stomata, you lose water. That just happens. And so when it's really prolonged periods of drought, you have to choose between making food and keeping water. If a tree is forced into that choice for too long, keeps its stomata closed, because if it opens, it's going to lose all of its water. It will die. Sometimes it creates, there's so much difference in pressure between the water that's in the soil and the dryness of the air that you get these embolisms within the xylem cells of a tree. The cells actually collapse because they're under so much pressure. It's like if you're sucking on a straw. If you had strawberry milkshake from Burgerville and like the big chunks of strawberry get stuck in the straw and then your straw collapses. It's like that. So much pressure that the cellular structure of the xylem cells collapses. And now nothing above that cavitation point gets any resource, any water. And so the top of the tree dies. You see this a lot in this area. You drive around, you know, Goldendale, the Dells, and you look at the ponderosa pines and you see all these dead tops. That's often a function of drought. It can also be a comorbidity with beetle infestations. Trees, when they lose water, when they become stressed, they lose the ability to pitch out insects. They just don't have as much sap to work with. And so they're more vulnerable to infestations by wood-boring insects. So, you know, you remove the fire that allows them to produce that resin. You increase competition for soil water because you've suppressed fires. Then you have this kind of like 1-2 punch on trees. Like you have now fewer resources to protect yourself and you're experiencing increased levels of stress. This is one model of predicted climate change. for this area, and you can see that, you know, we're on this like incline. That's pretty uncomfortable for the plants, and this is uncomfortable for all of us. It's really uncomfortable if you're a plant already living at kind of the extreme edge of where you can establish. And, you know, we live in that transition zone between forest and grassland, like we saw in this earlier slides. That line probably move as climate change advances, right? Those of us who are living in forests that are already showing signs of drought stress might someday live in a grass or shrubland habitat. So why aren't we just fixing the problem? One challenge is that the scale of this problem is massive, right? We've been suppressing fires for over a century. It's across the entire forested West. We have interrupted these fire cycles, and so it's a really big problem. It's also challenging that some of the non-commercial treatments, what I mean by that is, if you go in and do restoration by removing some of the trees, so you're trying to get back to closer to that historical density of trees that the site can support in a more healthy way. If you're cutting down trees that have commercial value, they're big enough to send to the mill, that work will pay for itself. That's wonderful. But if they're not big enough to send to the mill, it's really expensive because you're basically paying to cut them down, pile them, and burn them. And so it's an expensive problem. There's also a challenge around social license. We're going to talk about prescribed fire and the role that that can play in improving forest health. And it's a scary thing. You know, people are often responding to an emergency around wildfire. Why on earth would we intentionally put fire in the woods, right? Is what goes through a lot of people's heads. I'm going to try to illustrate how prescribed fire is not wildfire in a few minutes. But this is one of the challenges that we experience when we're trying to use the tools that we have available to us to improve forest health, and they experience social license problems. Another challenge is cutting wood. I mean, some people really don't feel good about seeing trees cut. In this case, we're trying to cut trees to improve the health and vigor and longevity of the trees we're not cutting, but it still necessitates cutting. And so that's a disturbance that really bothers some people. This is a map of the eastern side of the state of Washington, and this was taken from Washington DNR's Forest Health Plan. And what it shows is that we live in one of the areas that has been identified as the highest priority in the state to address the forest health crisis. That means in combination between the conditions that indicate that our forests are at risk of high severity fire, and that there's values in this landscape that could be compromised by fire. Those include people and their homes. It includes industrial forest land, it includes tribal values, and it includes habitat. And one of the cool things about where we live are the Oregon white oak. This is a plant that supports a huge number of wildlife species with its acorns. These are the most protein-rich source of plant protein in the woods. And a lot of animals rely on them for their nutrition. Acorn masting will drive entire cycles of animal populations. Deer often can twin, they can make two babies when there's a masting event because they have enough protein in their body to support that. So these Oregon white oak trees have kind of an outsized importance on wildlife habitat. This is a picture of a jay. Jays are the primary dispersers of the seeds of Oregon white oak. So acorns are lovely. You want to pick them up and put them in your pocket. My kids came home with like masses of acorns in their pockets whenever there's a masting event. People are dispersers of these seeds. Squirrels are dispersers of these seeds. But jays can actually plant 3,000 to 5,000 acorns every fall. It's amazing how much work they do. And of course, they can't eat them all. They'll forget where they cached some of them. And so score for the Oregon white oak, right? It's got this symbiotic relationship with its own seed predators. It relies on its seed predators to establish. Oaks also support an incredible diversity of invertebrates, insects. Between their leaves, their flowers, their lichen-encrusted bark, their mycorrhizal fungus that's in the soil, they support more than any other tree genus on the planet. The Quercus genus, the oak genus, supports more insect diversity than any other plant on the planet. Those insects in turn support a really wide diversity of birds and other wildlife. And the Columbia River Gorge and the Klickitat River are important parts of this feature called the Pacific Flyway. It's like one of the super highways for birds. When they're making their migratory journeys between winter and summer habitat, they fly through. And that's why our forests are alive. Like if you go out and sit in an oak woodland and you can hear the songs of these songbirds that are only seasonally present. That's why, because they're just moving through. Importantly, oaks are not the only generators of biodiversity in these systems, though they are a really important component of the diversity in these fire adapted forests. The understory forbs, the flowering plants that grow in our landscape, are incredibly diverse, and they all support different pollinators. And so when we're talking about the value of these systems, we're not just talking about trees. It's really easy to get distracted by just the big things. There is incredible things happening in the understory. I encourage you all to go crawl around in the oak understory someday and just look at all the things that are there. It's pretty remarkable. And there is kind of this new element in our understory that is complicating restoration, and it's complicating prescribed fire. And that is the presence of annual grasses. These grasses have names like Medusa head and ventonata and cheatgrass and ripgut. Has anybody heard of any of these grasses? Annual grasses? Okay, the reason that they're presenting challenges is because they love a good disturbance. They respond really favorably to fire, and they respond really favorably to increased carbon from climate change and to increased sunlight. And so then they reproduce really prolifically. They make a lot of seed and they grow every year. So they have gotten an edge on a lot of the native perennial plants that we have in the system. This upper left picture shows kind of the structure of what we would characterize as a native plant grassland. So this is like bunch grasses that grow in clumps, and then there's bare dirt in between. That bare dirt in between is where 70% of bee species in the state nest. When it fills in like that, their habitat is gone. There's also in between each of these clumps of grasses, there are clumps of flowering forbs, and those flowers all support different species of pollinators and insects that feed different species of birds. And so when you transition from a part of the landscape that has this richness to something that is dominated by one species, you see a precipitous decline in biodiversity and ecological function. The other thing that these grasses do is they change the hydrology and the fire history of your site. So they grow in that kind of dense continuous batch. It's really fine fuel. It's really receptive to flames. It carries fire. It's actually more flammable. It's been tested in a lab. They ignite before the perennial grasses ignite. And then they carry fire faster and across the landscape because there's no break in the fuel continuity of these annual grasses. The other thing they do is they have really shallow roots. And so when a fire does burn through and it burns most of all the grass above ground in either system, a fire is going to consume that material. Well, in those annual grass systems, you have about this much root mass that's storing carbon and transferring water from the surface in the winter all the way down into the soil horizons. You only have that much root mass. On these perennial grasses, you have about 4 feet. And so you have that much more carbon that's stored underground that's safe from fire. They'll resprout following a fire and continue to grow and deliver their ecological services. So these perennial grasses are really important in our fire adapted forests. We are still learning how to combat this challenge. We don't have the silver bullet to fix this problem, but we're working on it. We have a lot of monitoring projects underway. We're trying different herbicide and burning regimes to try to figure out if there is a way to safely and effectively and at large scale prevent this from happening in our forests. The other contributing factor to this transition from a perennial grass and forb dominated system to annual grasses is cattle grazing. These are plants that weren't adapted to spring grazing by domestic cattle. So, in the early 1900s, when we invited a lot of domestic livestock onto the landscape, we put them out in the spring. Makes a lot of sense because that's when the nutrition is available to cows, right? So the plants are most palatable when they're just germinating and when they're growing actively. before they flower. So it makes a lot of sense. That's when we would put the cows out. The problem is that's when these plants are trying to reproduce. So they can never make it to the flowering stage. And over time, they will fail to reproduce. And over time, they'll be replaced by plants that can survive spring cropping. So that is also happening on this landscape at large scales. I already talked about the effects of fire suppression on oak, where you get these kind of catastrophic fire effects. But you also have this problem where when you suppress fire and then Douglas fir, which typically is killed by fire as a seedling, starts to proliferate, and then it grows up and it overtops the oak. And the oak cannot survive in the shade. If there's an oak underneath a conifer, absolutely the oak was there first, because they will not grow without sufficient light. And so a lot of times when we're out in the woods, we'll see these big conifers and be like, this has always been a conifer forest. And then you'll see, oh, actually there's also a really big oak in the middle of it. It probably wasn't a conifer forest. That is a recent change. So as humans, we're really good at seeing the landscape right now as it always has been. Forever and ever. It's always the same. Peace. Things change. So what are we doing about all this different challenges? We're doing ecological forestry. And what that means is that we are taking equipment or people out into the woods, and we're removing some of that accumulated those trees, that biomass. And we're taking any profits, if we're able to sell any of that wood, we're taking those profits and we're doing more work. We're using the income that's generated from these projects to treat additional parts of the landscape that can't pay for themselves. We're also, as partners, Underwood Conservation District, Columbia Land Trust, Mount Adams Resource Stewards, U.S. Forest Service, Washington DNR, Yakima Nation, we're all collaborating to bring additional grant resources to this community. And you saw in that map that this is a state priority. They're putting their money where their mouth is. Like, this community is receiving a lot of funding through forest health initiatives, landowner incentive programs, and through large grants that are treating landscape scale treatments on conserved and public lands to address this problem. So we're making some progress, but we have a lot of work to do. This is an illustration of why the prescribed fire part matters. This is when we're going to start talking about prescribed fire. So in the top of this is all a landscape in Southern Oregon that burned in the Boot Lake fire. And the slide was of a project area that was treated by one of our partners, actually. They're called the Lomacotsi Forest Restoration Project. And they did a number of treatments here. This one, they only thinned the trees. So they went in with equipment and they cut trees down and they hauled them out and they burn and slash. The middle part was thinned and then they did a prescribed burn. And then the upper part didn't receive treatment at all. What are you noticing about the outcomes? It's a pretty powerful illustration of the prescribed fire benefit. Why do you think that happened? Why would prescribed fire change the outcome where thinning didn't? Surface fuels. Very good. Terminology 101, surface fuels. So I'm going to show you this next picture. This is a Columbia Land Trust property called Bowman Creek. And I was not thinking about this burn as a fuels reduction burn. I was thinking about it physiologically, like we're going to stimulate resin production in our trees and they're going to be able to pitch out insects and it's going to be great. This was a fuels reduction project. And the reason is because there was, 60 years of accumulated duff on the forest floor. And when we burn this, even in the shoulder season, when it's cooler and it's not windy and the fire doesn't get as hot, it generated enough heat to kill 70-foot tall trees. Oh. This is why prescribed fire makes a difference, because you have to address those surface fuels if you want to meaningfully reduce the risk of mortality in your standing trees. So what is prescribed fire? What are we talking about when we say that? It's basically any time you intentionally light a fire and try to control the outcome. That's a controlled burn or prescribed fire. Controlled burns are not wildfires. It's hard to kind of separate in our brain fire, like there's different types of fire. But just like there's different types of water, you know, there's swimming pools and there's the Columbia River. Same thing. Okay, so this is happening in a highly engineered environment. And like with any natural feature, there's an element of risk because fire is fire and it does have a mind of its own. But I'm going to walk you through how we create conditions that help control for that. This is actually just a slide to illustrate that any kind of burning is fuels reduction, and it's all meaningful. So there was an analysis by Kim Davis, she's in Missoula, where she did this meta-analysis of all the research that's happened in fire-adapted forests across the West over like the last, I don't know how many years. And she was looking at the effectiveness of fuels reductions treatments on subsequent wildfire outcomes. So she looked at stands that had been thinned, stands that had been burned. And what she found was that the best benefit was when you used a broadcast burn, a prescribed fire, to consume the surface fuels from the bottom of the forest. But then the next best thing was pile burning. And that's because you're still reducing the amount of available fuel in a fire. And so you have all that all that fuel is now removed from your forest. And when a fire burns through, it doesn't generate as much heat as it would if that material was still lying on the forest floor. So slash pile burning, if you can't get to the broadcast burn, it still leverages a benefit in these forests. So I'm going to talk to you about a broadcast burn, and that is when you try to have the fire move through the forest and not confined to a burn pile. So broadcast burning in the months before a burn, you're preparing your unit. So you've gone to the effort of laying out where you want the burn to happen and how you're going to establish control lines where you don't want the fire to cross. And then you prepare. And so sometimes it's removing fuels that might act as ladder fuels, especially along the margins of the control area, because you really want the fire to stay in the box. You don't want to have like big beastly flames right on the edge. So you try to remove some of those ladder fuels around the edges, and then you create mineral soil. And fire won't cross mineral soil because there's nothing to burn. There's nothing to carry it. This is what it looks like after a burn. And you can see in this case how effective the control line is. Now you also have people there, so talk about that too. But this is a primary tool for establishing control lines around fire. Another really important element of our burn program is monitoring. We want to understand what the fire is doing, why it's doing what it's doing, and how we can use that information to inform future burns. And so this is just a weather log, but I'm going to show you some examples of the types of information that you get from our monitoring efforts. So this is showing you what the flame heights are and the rate of spread when we started the fire at 10:50 in the morning. During this part of the burn, the temperature was 55 and the relative humidity was quite high. It was in the 40s and the wind was light and very low. And then 10 minutes later, it's starting to warm up a little bit more, but we're still getting pretty similar fire behavior. By noon, the RH has dropped in the 30s now. Temperature is getting warmer, but now we've moved into a different fuel type. There's grasses under oak. They burn differently than needles gas under ponderosa pine. And now here midday, you're starting to see a little bit spicier flame heights. The relative humidity has dropped into the low 30s and it's warmed up. So this kind of information helps us kind of calibrate how we want to design our burns. When do we want to light them during the day? What kind of fuel patterns are we going to put on the ground to create fire, the fire outcome that we want to see? Light fuels burn quickly and they carry fire faster.
Does that last all day? Or do you go into the next day with that, or those videos?
Yeah.
Is there an end?
Yeah, so the active flames are out by the end of the burn period. So what you do see though is still smoldering. So like those big heavy fuels might take many days to burn out. And so then we enter into a phase called patrol where we're watching and we're monitoring and we're mopping up, which means putting anything that's still burning within a certain distance from the perimeter of the control line out. using water and shovels and hard labor. For every burn, you have a pretty involved burn plan. This is just the checklist. The burn plan is usually anywhere from 10 to 15 pages, and it outlines what the wind speed can be and the direction that from where the wind is blowing. It outlines the range of temperatures that you feel like would be safe to burn within and still accomplish your objectives. Sometimes you have burn conditions that you can light the fire, but it's not going to burn hot enough to actually accomplish your objective, right? You're not going to get good fuel consumption. So you decide to walk away because it's not enough. It's not spicy enough. Sometimes you do what's called a test fire at the beginning of the day, and it's burning too aggressively and you decide to put it out. So that's those things can happen within the range of your formulated burn plan. Also, as part of your burn plan, you're identifying the types of equipment that you need to have present, your water resources, your personnel, like how many people you need to play the different roles that happen on a fire. You have people who are holding the fire, meaning they're armed with tools and with water, and their job is to make sure the fire stays in the box, stays within those control lines. A lot of their time is spent looking not at the fire, but at the part of the landscape you don't want to burn, right? Because embers can drift. And so their heads are on a swivel all the time. They're looking at the fire, they're looking over here, and they're watching for spot fires. You also have outlined how you want to do your ignition. So you show up at the beginning of a burn day. This is Lauren Clark. She's a burn boss with the U.S. Forest Service. She's basically telling people what team they're going to be on, what equipment they're going to have, and what their job is going to be on the fire. This organization is really important because you want to make sure that you have the resources where you need them to make sure that the fire goes off safely. So you have your briefing in the morning where you talk about the burn plan, you talk about the conditions. We spend a lot of time trying to poke holes in our own plan because if we're starting to make mistakes in our planning and our preparation, you really shouldn't go forward with a burn. It's just one of the kind of rules of prescribed burning. If there starts to be a lot of holes in the plan, pretty soon they'll line up. It's called the Swiss cheese effect. And you'll get an escape. So it's just important to always have high discipline when you're approaching prescribed burns.
So how big was that burn area? Or that burn?
This one that you were looking at, our units vary in size from about 10 acres to about 50. So it's variable, depends. And we're hoping by burning areas that are right immediately adjacent to each other, that we can do bigger burns in the future. When you first start, when you're reintroducing fire to the landscape, there's a lot more fuel out there than you really want a fire, than you want to have in the future. And so you burn that off in a more controlled way, and then you have less fuel to worry about in a subsequent burn. So those, what we call a first entry burn, are the ones where you're always attentive, but they're the ones that you're paying particular attention to because you want to make sure it doesn't get too hot, doesn't go too fast, doesn't burn down features you want to keep, like old big oaks that have big cavities. Ember lands inside an oak cavity, it can burn it from the inside out. So there's a lot of resources on the landscape you want to protect within your burn unit. And so you go pretty slow on those first entry burns, and you choose times when it's going to be a little cooler and maybe the fire's going to move slower or it's not going to burn as hot. And then once you've sloughed off some of that fuel, then maybe you can edge into a slightly warmer time of year or drier burn, and not run the risk of compromising the trees that you don't want to kill. These are just showing some examples of some of the resources that get deployed on burns. Communication is a big part of it, just telling people that this is not a wildfire. We do a lot of outreach to like the dispatch resources in the county, to the sheriff, to the fire district, so that they know what's happening. And then through public or social media, we try to get the word out to public so that they understand that this is not a wildfire. These are called pumpkins in the middle. They're just a way to refill the tanks on like the UTVs and the fire trucks without having to drive out somewhere else. So you can pre-position these as a water resource for your fire. when you're burning in a remote location. In this case, we were way up the Klickitat River, almost we were on the open part of the Yakima Nation Reservation. And so we wanted to have a lot of water present, outside of the creeks that we were also had pumps in. And then, these are just as an example of the hose lay, on the control line. So you have this long hose that extends the length of your control line, and you have little junctions where you have shorter hoses that have nozzles on them. And that way it gives you a lot of tools, access points where you can get water. So if you need to put out a snake that's caught on fire, or if the fire is moving up the trunk of a tree that you don't want the fire to go farther up the tree, you can put it out with these hoses.
Excuse me, so last summer there was a prescribed burn on top of Coyote Wall that got out of hand.
Yep.
And I mean, that was a couple of months before the big fire.
Yeah.
What's your percentage of fires that get out of hand? I mean,
Yeah, so that's where I was kind of referring back to the media. It's pretty rare. So that, the incident that happened with the US Forest Service is not very common. There's probably like a handful, in the last decade.
it was shockingly hot that day.
Yeah.
As a forest firefighter myself, I said, seriously, they're not starting that fire, and they did, so it was interesting.
Yeah. That's that tension between, we need to meet our objectives, and we need to be able to find burn windows that we can actually be successful with the burn. And we need to be respectful of that upper limit of where we think we can predictably maintain safety. And in that case, they had what's called a microburst. It was like a pulse of air that was unexpected, and it carried embers across the control line. They were able to suppress it. That's why you have in your burn plan emergency resources that you can mobilize if something like that happens. And so in that case, they were able to suppress it pretty quickly. And that's part of the burn plan. It's like having those contingency resources in place to respond if there's an emergency.
So who is this personnel? This isn't Forest Service.
These are a variety of personnel. So this is actually on Columbia Land Trust property, and federal agencies aren't allowed to burn on your property unless there's an agreement in place. So in this case, it was part of a training program called TREX. And these are nationwide collaborations between the Nature Conservancy and the US Forest Service and other agencies that provide training opportunities for primarily wildfire personnel. But increasingly, people who are prescribed fire practitioners have access to these training programs. And Mount Adams Resource Stewards is actually hosting another TREX event this spring to help train local practitioners in the art and science of fire. So there's a lot of training opportunities. And in this case, if a US Forest Service burn personnel wants to participate in TREX, then that gives them permission to burn on our private land. So it's kind of this interesting opportunity to leverage the resources of an agency on private lands while also advancing training objectives of the Wildland Fire Coordinating Group. So lots of different people come out for these burns. I'm going to show you some examples too where we didn't have those resources. It was just Mount Adams Resource Stewards and the local PBA, the Prescribed Burn Association. This is just another example of what it looks like on a burn. So in this case, this is an unsurfaced road that we used as a control line. Again, you can see that black that looks like destruction. All of that black is nutrients that are returning to the soil. So an important thing to kind of reframe in your head is that when you see black burned charred material, that it indicates death and destruction. It's actually oftentimes a sign of renewal. You'll see in burned areas that aren't really severely burned. So if you're seeing a lot of white soil, that's kind of bad news. That's like a really high severity burn. Black soil is just going to come back with this lush response from plants that suddenly have a lot more nitrogen, a lot more mineral nutrients to grow. This is some examples of other resources like, you know, the holding line with the fire, with the water. We have engines out there. That's my coworker Brad on the right with the drip torch. When you get an experience to drag a drip torch through the woods and participate in these burns in a way that feels more healing, it really is a pretty powerful experience. It's really fun to watch people do it for the first time. This is an example of some kind of spicier activity on the fire, and you can hear the burn bots talking about it. So in this case, you're see some of those smaller ponderosa pines. Those we expect the heat to kill, and that is by design. It's called thermal thinning. What we are wanting to do is reduce the number of trees that are growing out here. And fire does that in a really naturally selected way. So it's kind of removing trees from your forest in a way that is by fire's design, not by ours. We can have weird preferences for trees sometimes. Do you have your hand up?
Well, my question was like, what something could have been thin before there was a prescribed bond, that was part of the plan.
Yeah, and so this is where we're monitoring to try to figure out where the line is. Like, it's a coarse brush tool, right? Broad brush tool. So you're not gonna be like, save that tree and not that one, right? The fire's gonna do the selecting. Sometimes it's hotter than you want and you have more mortality than you wanted to have. Sometimes it's not hot enough and you have no mortality. You're like, now we just sloughed off all the fuel and we didn't kill any trees. So there's, depending on your objectives, you try to find the sweet spot, and sometimes you're a little off, and that's okay. Like I said before, nature's highly variable. Fire moves across the landscape in a highly variable way, and that's actually a good thing.
Is it fair to say that some of that, where that line is a bit of a financial decision? I mean, thinning all that manually would probably be.
Oh, yeah, no, if you
expensive.
can use fire, yeah.
So.
Yep.
Financial.
Yes, for sure. What we learned is that on our control lines, we want to have lower tolerance for these kinds of fuels because we don't want to create so much heat on the edge of the unit that it can potentially push embers out of the unit. And so we, even I think following this burn, decided we're going to do a little bit more prep along our control lines. But on the interior of the unit, yeah, we would not. But there's places where on the interior of the unit that you do choose to do some prep, and that would be if you're trying to protect a uniquely large tree, those old oaks with the big cavities, snags. Like, we don't want to burn up all of our snags. Snags are really important for wildlife. So we'll pull the fuel away from the base of the snag and create like a mini control line around the snag. You also have some ability to kind of like pull the levers when you're lighting the fire. So there's different firing patterns. You can drop a little bit of fuel on the ground and then walk 30 feet and drop a little fuel on the ground. Those are called dots. Those are going to spread pretty slowly and build heat pretty slowly. If you drag a line and then you walk 10 feet, or the next person is 10 feet from you and they're dragging a line, that's going to create a lot of heat because you're basically creating fire likes fire. So it'll draw itself toward, so flames will draw toward each other. And so if you light a line here and a line here, they're going to build this way. And by the time they get together, they're going to be creating a lot of heat. Whereas if you just have one line and there's no flame over here, it's going to advance a lot differently, less aggressively. So there's a lot you can manipulate just based on how you're putting fire on the ground and what pattern you're using. And that's something that you just kind of learn from people who've done it more than you have. And then you just watch. The best learning is just to be on the fire watching what's happening. This is an example of torching. Torching makes people real uncomfortable until you get used to what it is. Torching is when the fire will advance up a single tree and it ignites the canopy, the crown. Oftentimes these are Douglas firs or grand firs that do this. Needles have these chemical compounds called terpenes. And when they heat, they explode. And so you can actually hear it in the woods. It's like a crackling sound. Let's see if you can hear it. It's a kind of really kind of quintessential crackling sound that you can hear wood make. It sounds like there's wind and there's this sudden like burst of activity. The torching lasts for like 10 seconds, maybe. It typically won't spread to the neighboring trees because you're not burning in hot, dry, windy conditions, right? The conditions don't support movement of the fire through the crowns of the trees. So it's building its own heat and has generated enough heat to move up the tree, and then it burns itself out.
When you say you're not burning in hot weather, that's because you selected that weather. But
Yeah.
if that same thing happened in the middle of fire season,
If that happened in July with a 30-mile-an-hour wind, you would have a big wildfire. Yeah, so I mean, that's the difference between, you know, the wildfire and the prescribed fire, the swimming pool and the Columbia River. Like, this is a pretty low risk environment that you're intentionally putting fire in the forest. If it's high risk, you're not doing that. This is just another example of prep. So, you know, in this case, this person is trying to scrape out some wood that started smoldering on the inside of this oak tree. He's doing it for two reasons. One is because we told everybody on this fire that the oak are a high priority for us to protect. And so people were trying to protect them from burning down. And the other reason is because right behind him is one of our control lines. And so if you have a big piece of wood that starts on fire during the burn window, it could potentially smolder for days, weeks. You don't want something that's smoldering like that for that duration of time right against the control line. Because if conditions changed and maybe a month later it got hot and dry and windy, and then it kind of kicked up whatever was smoldering on the inside of that tree, now you have the potential to lose the fire. Because it can catch the crown on fire, and then it may be embers. There's an ember that lands outside the control area and all. So we try to pay particular attention to anything that's burning around the perimeter of the fire. By the end of the day, it looks kind of like this. Everything that is available to burn has likely burned. And then there's things that are smoldering around the perimeter. And so you use a combination of tools and water to do an entire workup around the fire perimeter. It's called mop up. And you're basically grubbing out those burning materials until there's nothing burning around the perimeter. And then you start a long process of patrolling and monitoring the fire outcome. These are insects that immediately moved into the burn unit right after the burn. So still hot, still smoky. All of a sudden there's all this insect activity. It's really cool to see wildlife respond to fires. We were watching Lewis's woodpeckers at one of our burns, like going into the smoke column for bugs. Like they were going in and they're coming back out again, digging it. So it was kind of fun to watch. And then, you know, within sometimes days, but often weeks, you'll start to see plants reemerging. A lot of these fire adapted plants have root masses that will just resprout. So they're protected underground and they'll resprout following the fire. A lot of things are regenerating from seed. But regardless, what you're getting is kind of this pulse of nutrients that feeds a new flesh plants. This is a ceanothus plant, and this is really important browse for deer and elk. And when it gets old and decadent, it develops these really woody stems and the animals become less interested in it. Following a burn, it resprouts and it's like all fresh and delicate again. It's really good browse for wildlife. This is 6 weeks post burn. You can see the control lines kind of right down the middle. It's kind of hard to see because things have started to grow again. But on the left side is the burn unit, on the right side is the not burned. And your aesthetic preferences are like, the right side's better, right? It's greener, it looks healthier. The left side though, what I see when I see that is again, this kind of like nutrient cycling that's happening in the understory, but I'm seeing all these small dead pines back there. That is the objective, is to kill those trees. And so on our next burn, after those have fallen over, we're gonna have, you know, this much lower density stand that we're working in. And over time, after subsequent burns, you start to see this kind of mature structure that emerges where the big trees have more resources, they're healthier, they're pitching out insects, they're possibly growing faster than they would if there was still competition for resources. And you don't have these potential small trees that could bring wildfire up into the crowns in those hot, dry, windy months when you don't want your forest to experience wildfire.
So how often are you going back and reburning the same area?
Yeah, it depends on the site.
Depends upon
Yeah,
where it is in the plan.
yeah,
How
exactly.
many times?
Yep. Yeah, and it depends on how quickly the fuels rebuild to the point where you have something burn again. So, you know, these will be unavailable to burn for probably several years while that all the leaf and needle casts start to rebuild. And there's grasses developing in the understory. So until that happens, we won't do a reentry burn. Mount Adams Resource Stewards has now done their second entry on multiple units. If you go up and drive into the Convoy Lake National Wildlife Refuge on the entry road from the highway, that's all Mount Adams Resource Stewards Community Forest. And you can see that those units have been burned multiple times. And so when you're driving through there, if you do, you should just pay attention to that you're in a forest that has experienced fire on like a 5-year fire cycle for at least the last 10 years.
Then how do you establish another generation of trees eventually if you're burning?
Because of the variability of fire. So even within our units, there's whole areas that get skipped because fire just does that. And so all of these forests are kind of adapted for that. That clumpy gappy feature is a feature of fire. So you do end up with recruitment. It just happens in a kind of scattershot way. The other thing that fire does is it creates openings. It creates gaps in the forest where there's a lot of sunlight. And one of the important features of a gap in a forest is that there's less intercept of snow and precipitation by the trees. So you get deeper accumulations of snow in openings. That's why often the snow melts faster under the trees than out in the openings. You know, if you're a hiker, you notice this on trails. You like get out and do a little opening and now you're like slogging through the snow. It's because more snow was able to contact the ground in those openings. And that's really important for like saturating the soils with water for a late season or for, you know, spring melt. So those openings are actually important features to capture more water in the soil for these forests than they would have if there were no openings. This is just a pre-picture. So again, you're going to train your brain to see this fire effects in a new way. This is right after the fire. And then, so this is what you're seeing, like maybe the day or two after the burn. So things are orange and singed, there's orange and black. By the next photo, you're starting to see, now it's fall, of course, so it looks different. But now you're starting to see some actual tree mortality, like this tree on the left is fully dead now, even though it only burned down here. So you can start to see some of those effects. We'll be retaking some of these photos in the spring to show how it starts to look on the recovery side of things. This is an example at our Bowman Creek property. This is in a power line right of way where the PUD came in and just dropped a whole bunch of trees and then walked away. This can generate a lot of heat if it were to burn in a wildfire. If we burn it in the shoulder season, we can get rid of a lot of that material. As another example, kind of a lighter fire effect where you're just kind of consuming those small limbs on the ground and the leaf litter. This is another one. So I mentioned before that we try to prep our units to prevent the loss of things like snags. In this case, Ian, you're not always successful. In this case, this one was not prepped. I can tell by looking at the ground around it in this photo. And we burned up that snake. That snake's gone now. The other thing you can see in these photos, it's a little bit hard to see actually in this one. On the far left, you can kind of see there's these low growing limbs on the trees kind of in the back. This is what I mean by the pruning effect that fire has, where if a tree is big enough to survive the heat from the fire, because its crown is up high, it's elevated, then all the lower limbs that get burned, they get singed, are gonna die. And they're gonna drop their needles, and it's basically gonna elevate the height of the live crown. So the part of the tree that's still green gets farther from the ground. And that's really good for future fires because you're preventing fire from entering the crown of the tree. Threw this photo in here just to make sure I talk a little bit about the Mount Adams Prescribed Burn Association. Has anybody heard of that? Okay, a few of you. This is a really cool effort by local organizations Columbia Land Trust, Sustainable Northwest, and Resource Stewards created a PBA, which is basically like a community of people who are interested in helping each other burn. And the PBA is securing resources using public grants like engines and tanks and tools and fire resistant clothing that people can access if they want to try burning on their own property. It's also really cool because it pools resources. So if you want to burn and you're willing to show up for someone else's burn through the PBA, then you are part of a community of, 50 people who on burn day are going to show up and help you burn, right? Half the battle on these burns is having enough people where you're seeing what's happening and you're using your tools effectively to keep the fire doing what you want it to do. So the PBA is a really great tool to leverage our bodies to do more of this work without the huge grant awards and the, US Forest Service personnel and their big engines. We can do a lot of this work just with our bodies.
Which is how farmers used to farm.
Absolutely. Yeah, there's PBAs across the nation and there's some that still do, right? They all show up, they burn like 1,000 acres of cropland with a truck, the water tank in the back. I mean, it's super cool, all the different models that have emerged around the United States. In our region, our forest service is so far out of whack, and we work in this kind of interesting weather corridor where there's a lot of wind and some added complexity to burning. And so we have a need for like learning this art again. And so we're using these opportunities with trained personnel through treks to train the people who lead these PBA burns. And then the PBA is allowing people who don't have training to engage with fire and to feel safe and to have a role in how those burns happen on even small private land ownership. So I can't remember how many burns the PBA has done to date, but several on small private land ownership. So it's a pretty cool tool. And if you want to be part of that, you can. This is an example of someone using their big burly muscles to do fuel reduction. This is my coworker Adam, but you don't have to do the heavy lifting. There's a lot that you can do with your body, and there's a lot that you can do with your mind. One of the most important things, because we live in this fire adapted forest landscape, we are going to experience fire. It is like a fact. It's the only certainty you have is that you will experience fire. And so what you can do is help prepare your home to experience fire in a way that resists the negative effects of fire. And there's a lot of resources on UCD's website. There's a publication that Oregon State University put out specifically actually for the community of Hood River, but it's largely applicable to where we live, called Before Wildfire Strikes. Has a lot of really great information about how to harden your home against wildfire. So even if you live in the middle of White Salmon, you are still at risk of wildfire. And so it's an important thing just to think about. You probably want to remove like the types of plants, like my mom's house is surrounded by arborvitae, and there's like juniper-like trees that make beautiful screens for privacy. Those things burn like mad. If you have those around your house, you should go cut them down tomorrow. It's not worth it. They're like torches. I have some weird juniper-y, like low growing shrubs, and I decided to cut them back a little bit because they were kind of getting close to my deck. And I went down to burn them, and I lit those things on fire, and I was like, oh, they're all coming out. They were like, so different plants will burn differently. And you want to make sure that your landscaping around your home are fire adapted plants that are not going to like combust and create a firestorm at my house. The other thing you can do is you can join the Mount Prescribed Burn Association. Anybody can join. All you have to do is be willing to show up when our collaborators are doing burns and help out. You'll have guidance, you'll have safety, and you'll get to learn a new relationship with fire. So it's pretty stinking fun. And this is something that can be multi-generational. It's pretty accessible. Yes.
I could comment on that. I volunteered at a PBA burn last fall.
Nice.
It was a lot of work.
Yeah.
I really felt it when I went home, but it was really informative. I used a drip torch I got to put out fires along the perimeter. I got to deal with an irate neighbor.
Oh, that's
It
fun.
was definitely an experience. So if it's something that you're
Yeah.
interested in, I would recommend it.
Yeah, it's pretty fun. You can also be an observer on burns. So if you feel like, you know, your abilities are limited, you can still participate. There are also multiple websites that can help you understand about the ecology of the region and resources that are available to you to help with preparing your landscape for burn. Mount Adams Resource Stewards has a website. East Cascade Oak Partnership has information that's very specific to oaks. So if you have oaks on your property and you want to know more about how to manage for those, it's a great resource. And then there's a website called thewestisburning.org that has a movie and some other materials to help you understand kind of the policy and the history that landed us where we are with fire. And then, you know, one thing you can do is when you hear people talking about prescribed fire, you can share what you learn. You can help people understand that fire is this coarse tool and it's really critical to helping our fire or our forests withstand future wildfire. We saw in those pictures what surface fuels will do to big mature trees. That's true all across our landscape. So the more prescribed fire we can put on the ground, the better off we are, and the healthier our forest will be. So I think helping people understand that there is some risk. There's a lot more risk to our communities of not doing it than there is in doing it. And that risk is way more widespread. It's a bigger problem than the risk of putting prescribed fire on the ground.
So apropos of the risk, does Columbia Land Trust or any of these other organizations do anything to advocate for Clickitat County to change their ordinance allowing fireworks on July 4th?
We don't get involved in the firework ordinances. You know, there's a lot of entities that are trying to position themselves to influence policy.
Yeah.
And I'd say some of the most impactful policies are the ones that limit the ability to do the prescribed burning when you need to be able to do it. So, you know, the burn bans go on when there's no risk of fire carrying through the understory. We need the fire to carry through the understory to do a prescribed burn, right? But you don't want just anybody, you know, lighting a fire. So it's tricky. It's really hard to provide rules that keep the community safe and empower the kind of management that we need to do. And so we are working with the DNR. There's a Washington Prescribed Fire Council that is organized specifically to address some of these policy and funding issues. There's now in Oregon, there already is, and in Washington, we are building a liability risk pool like funding, so that if you do a prescribed burn and you're within the descriptions in your burn plan and something random happens, say a pump malfunctions and you don't have water when you need the water, and a big gust of wind comes up at the same time, right? That Swiss cheese effect I was talking about. And a fire lands outside the box and you need to call for support resources, you won't be liable for the suppression costs because there's a burn plan in place with a permit. And so it limits your liability for suppression if you followed your burn plan. And then if there is a loss, like say the fire burns down your neighbor's cattle fence or something, and you have to pay for the replacement, that fund would kick in. So it just addresses some of the barriers that exist for private landowners who want to use fire as a tool. That's all I
I
got.
have a quick question on weeds. What kind of effects are you seeing on weeds?
Oh man, so all the plants in the understory, they respond differently by species to fire, and they'll respond differently based on the timing of the fire, the heat of the fire. So it's I'm uncomfortable trying to characterize like generally how weeds respond. I was sharing earlier that those annual grasses respond pretty favorably to fire. And so we're trying to tease out like what's the best window of time to burn to dampen that effect. And then what if we follow it with like this herbicide that's very specialized for annual grasses? what if we do that before we burn and then we seed 2 years later? Like, we're trying all these different kind of mishmash of approaches to try to suppress the weed response for annual grasses. Other plants, there's a lot of native plants that are weedy in the sense that they really like disturbance, and so they'll flourish right after. And then they'll kind of peter out as other plants move in, the plants that are slower to establish after a disturbance. So I think there's still a lot of monitoring and learning that has to happen for the understory plants. But it certainly, what it does is like invigorates the understory. There is a amazing response. Like, all these plants are growing pretty vigorously. Weeds and not weeds alike. Yeah.
I know there are programs to help private landowners thin their property.
Yeah.
But they also allow chipping.
Yeah.
So they are spewing all this chipping under these trees, you know, this forested area.
Yeah.
That seems like you're just adding more fuel.
Yeah, so there's different ways of dealing with slash in the forest, and one of the concerns of not doing anything, like if you did the thinning project and you just left the slash in place, is that it can create conditions that attract forest pests. It can create kind of this lofted fuel that could serve as ladder fuels. And it generates heat when it burns. That finer material burns differently because there's less oxygen, like it's kind of packed in. Burns a little differently. Ideally, you would be chipping and then moving those chips somewhere that you need them, like on an unsurfaced road or something like that, where they're doing less damage. I have concerns about chipping programs because that coarse wood, if it's really thick, it prevents all the native plants from germinating and growing, and it promotes species that enjoy coarse wood inputs. So a lot of times it's things like hound's tongue and knapwoods and thistles that can endure in those kind of hardier environments. So I encourage you to think critically about where chipping is appropriate and where you might want to prioritize a different tool for dealing with slash. It's a good point.
Go ahead. I'm gonna watch with interest this spring to see how the oaks that got scorched
Yeah,
by the really quick and fast
yeah, me too.
understory burns of grass. Like, are the small branches up to where they normally sprout in the spring for new growth? Or is it gonna start there? I know that I doubt if any of those trees, very many of them, are killed, but I wanna know at what point down the tree
Will they generate
they'll
new buds?
regenerate. Do you
Yeah.
have any clues or any experience with it?
Yeah, I mean, what I've seen is that most of the branches will produce new growth. If the branch was burned hot enough to damage the buds within the bark, then they will not. So you'll only see leaves develop above whatever point that was where the heat was hot enough to burn through the cambium and damage the bud. So it's variable. It just depends on the conditions at the time of the tree burn.
So if the leaves aren't there, if it was like so hot for those particular trees that it actually didn't leave the scorched leaves there for us to see all those brown leaves,
Yeah.
and it actually burnt them, then
I
that
see what
might be
you're
a
asking.
little too hot.
Right, yeah, so you're asking about what are some of the indicators that we could use following a burn to predict whether the tree's gonna survive or not survive and where it will still have. I think it's honestly, it's kind of hard. I don't know that yet.
Yeah, me neither.
Yeah.
It's just gonna
That's
watch
one
it
of our-
with interest.
Yes, that's one of our hopes is that we can start to correlate some of those, like the burn severity indicators with like the predictor of how the oaks are gonna respond. I've seen oaks get like torched, the leaves burn up, and then they are just fine the next year. So I think it really depends on how the heat interacts with the buds and whether or not, you know, the buds have been damaged or not damaged. Sometimes the leaf will flame. And sometimes oaks will retain their leaves, right? They do this actually in the absence of fire. It's called, what's it called? I just lost the word. Recession? What's that?
Like dehiscence?
Yes, it's like that. This is my.
Yeah.
mid-40 spring. Marcescence, that's the word, marcescence. Marcescence is when the leaves die, but then they stay on the tree. And one of the theories about why they do that is to protect the next season's buds from browse damage. And so in fire, sometimes we see the same thing, like the leaves are essentially like kind of like frozen on the tree. I've seen them actually where they were like blowing in the wind of the fire and then they freeze all in the same direction. And you're like, whoa, that's wild. And those trees still leafed out. So it's really, I just think it's kind of hard to know. But if you start noticing, I want you to email Oaks at Columbia Land Trust and share what you're seeing. Seriously, you know, you all are in this landscape and you're making really valuable observations every day about the world around you. There have been landowners who called in to the Department of Agriculture because they saw a weird bug and they're like, I think it's this thing. And they're like, no way. And they go out and they're like, it is, you know. So don't, you know, diminish the importance of your observations to learn more about this landscape. You can learn a lot just by paying attention, being curious. I love that you're asking that question. I have a question too. Yeah.
I'm imagining my homeowner's insurance company when I say, you know, I'm thinking about a prescribed burn.
Yeah.
But then I'm imagining not telling them.
Yeah.
Are there resources? Do you have any ammunition for someone who's considering?
That's a good question. And I'm not an attorney. I give you legal advice, and nor am I an insurance provider. My understanding would be the same as if you were burning slash on your property. I don't see that as necessarily very different. And like, I don't notify my insurance provider when I go burn a pile of slash on my property. Like, that's not a thing I do. I think there's a kind of imperative for the prescribed burn community to do a lot of outreach to insurance companies. I actually think they do understand the value of prescribed burns as a tool to reduce risk.
More and more, but
yeah,
not there yet.
Yeah, so like there's the risk in the moment, and then there's the mitigation that it has for like 5 to 10 years after you do it, right? And that's what the insurance company should be thinking about. Of course, they're going to be worried about the risk to your structure during a burn, but in a prescribed fire, I think the argument you could use is that in the shoulder season, when you're doing a prescribed burn, the risk to your structure is incredibly low. Whereas the benefit you're getting from a future wildfire interacting with your property is incredibly high. So I would just really focus on that if I were to communicate with them about that. For Columbia Land Trust, when we're burning, we did have this conversation with our insurance provider, and we are a private landowner. And they're allowing us to use prescribed fire as a tool, and we just have to follow our burn plan. So we submit to them our burn plan and our permit, and then we're covered.
Okay.
So if we have an escape or if there's a claim against us for something, they'll cover it. So I think maybe different insurance providers have different attitudes about that, but yeah. Right. Thanks.
Thank you.
Your mid-40s brain has amazed us all tonight. That's amazing. And thank you so much for sharing such a wealth of knowledge and information here. I hope you can all share it with your neighbors. Again, we hope to post the recording on our webpage in a week or so. And so point people to that if you want to share this information as well. And stick around, have some snacks, ask some questions. So thank you for coming tonight. Thank you.
Okay. So you want to do your video recording thing, magic? Yes. Your magic. Nice to see you.
Yeah. No, I know you can make this.
When you told me about it, what did the nights that already happened?
Every year. Yeah.
It's like next year, I would think like if everybody's doing here, you know, like mix it up a little.
Yeah, and it's
Like we saw some of the. Yeah, I my first job in there, you know, I think I received some of it. Yeah, I started out.
Oh, wow.
Yeah.
It's called 2003.
Yeah. Yeah, I wonder how long it's gonna be. Yeah. I was actually thinking over another presentation that I thought so good. I was just I thought she was gonna do the same. Like totally. Yeah, it's really like so much cool stuff going on out there. It's something like this. Yeah. I know, Kirill and I are trying to figure out the biggest work, but she's, you know, waiting on. So trying to come up with a clear plan.
So fun.
Yeah. And so kind of natural. Yeah, no, good, yeah. But it's like that too. Yeah. 26, yeah. October, right, well, that one, like, October sometime, but yeah, you could, you'll get on. Yeah. Yeah.
During that. Several of the time. As far as the very beginning, like. Or. Yeah. Yeah.
Yeah, maybe here.
Yeah. I know, well, neighbors, you know, we have their neighbors, that once they understand, kind of like. Actually.
Right.
What happens in.
Yeah.